Welcome to The Explainer. Sometimes the best questions, the ones that really make you think, are the ones that feel almost too simple to ask. Today we're diving into one of those questions about speed that gets right to the heart of how we measure our world in motion.
And we're going to start with this thought right here, from Reddit user Brother Ericus. Let's just get this out of the way right now. It is not a stupid question. In fact, it's a brilliant one that I'm willing to bet a lot of us have wondered about at some point.
And here it is. This is the core of it. How in the world can we talk about our speed in kilometers per hour when the trip itself doesn't even take an hour? It feels like it doesn't make sense, right? Well, today we're going to unpack this and show you why it absolutely does.
To really get to the bottom of this, we've got to back up just a tiny bit and make sure we're all on the same page about a couple of really basic foundational ideas. And it all starts with the simple concept of motion.
So, before we can even have speed, something has to be moving. And motion is just a fancy way of saying an object is changing its location compared to something else. That something else could be the ground, a tree, a building. You get the idea.
Okay, so if something's moving, how do we talk about how much it's moving? Well, that's what speed is for. It's literally just a measurement, a tool we use to put a number on how quickly that object is changing its position over time.
Now for the fun part. Let's look at the math that brings this all to life. And don't worry, I promise it's beautifully simple.
And there it is. That's the whole thing. Distance divided by time equals speed. To figure out how fast anything is going, you just need to know two things. How far did it go, and how long did it take to do it?
Let's make this real. Picture a sprinter in the starting blocks for the 100-meter dash. They've covered a distance of 100 meters, and let's say they did it in a blistering 10 seconds flat.
So we just plug in the numbers. We take the distance, 100 meters, divided by the time, 10 seconds, and boom! You get the sprinter's speed, 10 meters per second. Easy, right?
And what's so great about this formula is it works for anything. Let's switch gears completely. Now we're at a swimming pool. An athlete swims one lap. That's 50 meters, and it takes them 25 seconds.
It's the exact same math. 50 meters divided by 25 seconds. The swimmer's speed is 2 meters per second, slower than the sprinter, for sure, but we calculate it in the exact same way.
Okay, so now that we're all pros with this simple formula, let's circle all the way back and solve that original mystery from the Reddit post. Let's crack the case of the 14-minute walk.
We can do this in just a few steps. The first one is the biggest aha moment, realizing that per hour is a rate, it's a ratio. It's not a rule that you have to travel for a full hour. Once you get that, the rest is easy. We just need our units to match, so we turn 14 minutes into hours. Just divide 14 by 60. Then we plug it all into our trusty formula.
And when you do the math, there's our answer, about 4.3 kilometers per hour. And here's the key to what that number actually means. It means you're moving at a pace that, if you kept it up for a whole hour, you would cover 4.3 kilometers. It's a snapshot of your speed in that moment.
Another Reddit user, Aaronite, just absolutely nailed the explanation right here. Kilometers per hour isn't describing a journey that has to take an hour. It's just a standard way of talking about a rate of speed, so we can compare that 14-minute walk to, say, a 3-hour car ride on the same scale.
Okay, so we've got a handle on speed, but now let's throw in a little twist. What happens when the person doing the observing is also moving? This is where things get really, really interesting, and it's called relative speed.
The key idea here is something called your frame of reference. It sounds super technical, but all it really means is your point of view. And here's the wild part. How fast something looks like it's moving completely depends on how fast you're moving.
I know you've experienced this. You're driving down the highway, going, let's say, 30 kilometers per hour. The car in the lane right next to you is also going 30. You look over at them, and it's like they're just floating there, perfectly still beside you. Relative to you, their speed is 0.
But let's change your frame of reference. You're not in a car anymore, you're on a bike, cruising along at 5 kilometers per hour. That same car going 30 kilometers an hour zips past you. From your point of view on the bike, is it going 30? No way! It feels like it's going 25 kilometers per hour faster than you are. That's its relative speed.
And this is why this stuff really matters. It's not just some abstract physics lesson. As physics teacher Ray Burns says, this field, which is called kinematics, it's unfolding all around us every single moment of every single day.
So what have we figured out today? Well, speed is just a simple ratio, distance over time. Units like kilometers per hour are just a handy rate, not a stopwatch for your trip. And how fast something seems to be going all depends on your own frame of reference. But maybe the most important takeaway is this: it's never, ever a stupid question to try and better understand the world around you.
I'll leave you with this final little brain teaser to chew on, a classic physics puzzle that ties all these ideas together perfectly. What would happen if you were standing still and you jumped onto a moving train? How would your speed change relative to the ground and relative to the train itself? It's a fun one to think about.